I'm going to divide it up for this section. I'm going to divide it up into a couple of different parts because adding and subtracting rational expressions, we've got to talk about how to find a common denominator, what happens when you have like denominators, and so on. The first ones we're going to do are rational expressions that have like denominators. So if you'll remember when we just do normal fractions, if you have the fraction 2/5 plus 1/5, well, if they have the same denominator, you keep the denominator and then you just add the tops. 2 plus 1 would be 3. Same thing's going to happen with rational expressions. If you have the same denominator, then we're just going to add the numerators and combine, pretty much combine like terms. Then at the end, we'll check to see if we can simplify. This is what they did in this example. In this example, you had to be careful because there was a subtraction sign. So when you have a subtraction, you have to distribute that subtraction sign through. That's where they got the negative 6x here and the positive 17. So be very careful, especially when you have subtraction and we're doing these. So this first example, we have a 17x in the bottom. So that's the same denominator. I'm going to leave it alone. 22 plus 7 would be 29. And that's all you can do with that one because there's not any common factors between 29 and 17. That's all we can do. On this next one, I have b minus 5 as my denominator for both of those. So b minus 5 carries over. 17 minus 11 is going to give me 6. And so I cannot cancel a 6 with either the b or the minus 5 on the bottom because we can't cancel that way on these rational expressions. So you see some of these are going to be very straightforward if they have common denominators already. All right, this next one I've got a y minus 1 on the bottom. So I have y minus 1. And I've got 8y squared minus 8y. Well, I can't combine those because they're not like terms, so I'm going to bring them over and just write them. Now, I'm going to look at 8y squared and 8y, and I'm going to say to myself, can I simplify that at all? Sure, I can take out an 8y from both of those. And if I divide that out, because I'm doing a GCF, I'm going to have a y minus 1 left. And then I have a y minus 1 on the bottom. Now those would cancel, and I'm left with 8y. Sometimes you can simplify these, sometimes you can't. It just depends on if you can factor at the end and then cancel anything. This last one, I've got x minus 2 as my denominator for both of these, so I'm going to carry it over. This is an addition, so I'm going to put those together. X squared minus the 5x plus the 6. Now I'm going to see if I can factor the top. I need to find factors of 6 that add up to a negative 5. So that would be negative 2 and negative 3. So the top would factor into x minus 2, x minus 3, and I have an x minus 2 on the bottom. So you can see x minus 2's will cancel. So I'm left with x minus 3 for my final answer. So when you're working problems that have like denominators already, keep the like denominator and then combine the numerators. And if you can factor at the end and cancel, then factor at the end and cancel. All right. The next part of this is what are we going to do if we have unlike denominators? Well, if you will remember, when we have done fractions before, similar to this, 1/3 plus 2/5. Those are not like denominators. 3 and 5 are not like denominators. So we had to find a common denominator between 3 and 5, a number that 3 and 5 will both go into. Well, that would be 15. So what we would do when we would be adding fractions, we would change both of those to something over 15. We would say 3 times 5 is 15, so 1 times 5 is 5. 5 times 3 is 15, so 2 times 3 is 6. So I've made equivalent fractions, 5 over 15 plus 6 over 15, and then you'd add those and get your 11 over 15. That's what we do when we just have numbers. So when we have expressions in the denominators, the way you will find a common denominator is you will first of all factor all of your denominators. I'm not really going to concentrate on ones like this. I don't do the prime factorization to find the LCD. I just look at the largest number and start making a list of its factors or what it will go into, and then match the 12 and the 6 in this case with the 18. So for instance, I would say 18 times 1 is 18. Well, 6 goes into it, but 12 doesn't. So move on to the next. 18 times 2 is 36. 6 goes into 36, 12 goes into 36, so I know 36 is my LCD. That's how I do just numbers. But now in the next one, we're talking about expressions. So the key thing is you've got to factor each expression in the denominator first. So in this example, x squared plus 2x plus 1, they factored into x plus 1, x plus 1. The second fraction has an x squared plus x on the bottom. I can take out an x from both of those. So I have an x times x plus 1. Now, in my LCD, I have to have every parentheses, every factor represented. So what I do is I will write down whatever I have in the first fraction. It doesn't matter what's in that denominator. I know it's got to be in there. In this case, I have an x plus 1 and an x plus 1. In the second denominator, I have an x by itself and an x plus 1. So I need an x by itself in my LCD. The x plus 1 that's in that second fraction is already represented with one of these x plus 1s that I have. So then that would make my LCD. The only time you write two of the same parentheses in your LCD is if you have two of them together in one denominator. And this was a case where I had two of them together in one denominator, so I need two of them together in my LCD. And we'll work some more like this. All right, so in these next problems, we're not doing any adding or subtracting. We're just finding LCDs. So it's going to take a lot of factoring. We're going to spend a lot of time factoring. So in this first one, factors of 10 that add up to 7 would be 5 and 2. So x plus 5, x plus 2. In the second fraction, I've got x squared plus 4x plus 4. So factors of 4 that add up to 4 would be 2 and 2. So x plus 2, x plus 2. So then my LCD, I'm going to write down what's in the first fraction, x plus 5, x plus 2. In the second fraction, I have x plus 2, but I've got not only one of them, I have two of them. So if two of them are together in the one LCD, I have to put two of them together in my final LCD. So the only reason that I wrote two of them in my LCD is because these two were together. That's the only reason. If I had just had a single x plus 2, I would have just needed a single x plus 2 in my LCD. But in this case, I need both of them. All right, number 6, this is more numbers. So we're looking at 6, 12, and 9. Choose the highest number. 12 times 1 is 12. 6 will go into it, but 9 will not. So I'm going to go to the next one. 12 times 2 is 24. Again, 6 will go into it, but 9 will not. 12 times 3 is 36. Aha, 6 will go into 36 and 9 will go into 36. So I know the number part of my LCD is going to be 36. Now, with exponents, we're going to choose the smallest. I'm sorry, I'm not choosing the smallest. We're doing LCDs this time. We are going to choose the largest of the exponents. So when you have exponents, we're going to pick the largest. I was thinking about trying to do GCS. I've got to think the other way. All right, so for x's, I've got an x cubed, an x squared, and an x. So the largest of those would be x cubed. For my y's, I've got a y to the 1, a y squared, and a y cubed. Y cubed would be the highest. For my z's, I've got z to the 4th, z cubed, and a z to the 1. So I need that z to the 4th. All right, so far so good. All right, let's look down at number 7. The first fraction is already factored, x minus 2. You can't change anything with it. So I'm going to look at the second fraction, x squared minus 4. That's the difference of two squares. So that's x plus 2 and an x minus 2. All right, so x minus 2. So for my LCD, in the first fraction, I have an x minus 2. In the second one, I don't have the x plus 2 yet listed yet, so I'm going to list it. Now, in this case, I have an x minus 2 in that second fraction. I already have it listed in my LCD, so I do not have to list it again. Again, the only time you have to list it twice is if they appear together in the same denominator to begin with. Up here, these appeared together in the same denominator, so that's why I had to have 2 of them included. If I don't have 2 of them together, I don't have to write them twice. Okay, let's do this last one. I've got x squared plus 6x plus 9 on the bottom, so that's going to be x plus 3, x plus 3. So on this one, I'm going to have 2 of those in my LCD. All right, for the x squared minus x minus 12, factors of negative 12 that add up to a negative 1 would be x minus 4 and x plus 3. So my LCD, since I have 2 x plus 3's together, I need to have 2 x plus 3's in my LCD. So then let's look and see what's missing from the second one. I don't have an x minus 4 that's in the second one. I need to put it. I have an x plus 3 in the second one. It's already covered with either one of these that I already have listed. So there would be my LCD. All right, equivalent fractions. So remember when I was doing the problem earlier, and we had, what was it, 2/3 plus, let's just do 1/5, same thing. Remember I said that the LCD between both of those was 15. And then after we decided what the LCD was, we changed each one of those fractions to the new fraction using that LCD. So that's called making an equivalent fraction. And the way we did it was we said, okay, well, 3 will go into 15 5 times. So 3 times 5 is 15. I have to do that to the top. That would make me a 10 over 15. 5 goes into 15 3 times. So 1 times 3 on top gives me 3. And then you could add. I think that's different than one that we did just on the previous page, but you get the idea. So what needs to happen is I play a game called What's Missing. And what I will do is I will look at the old denominator to my new denominator, and I will ask myself what is missing. Whatever is missing will get multiplied times your numerator. It's a lot easier to see than it is to hear that. So, for instance, I'm going to look right here. From my old denominator, x minus 2, to my new denominator, x minus 2x plus 2, I'm missing this x plus 2. So to make an equivalent fraction, I have to take the x that's on top and multiply it times x plus 2. Well, that would give me x squared plus 2x. Okay, so that's kind of how I play it. I'm not really paying much attention to their directions. I'm trying to give you the easiest way that I think it's easy to do. So first of all, everything has to be factored again. I think I've said that about 15 million times in this chapter. You need to factor. So before I can make an equivalent fraction for this a, I've got to factor on the bottom. So I need factors of negative 2 that add up to negative 1. So that would be a negative 2 and a positive 1. Now, to make the equivalent fraction, start with your x plus 1 right here. From the old to the new, I'm missing the x minus 2. So I need to take 5x times x minus 2. Okay, so when I multiply that out and clear my parentheses, that would give me 5x squared minus 10x on top of the x minus 2, x plus 1. Are you getting the idea? You play what's missing. Whatever's missing gets multiplied times that numerator. So on this next one, when I factor x squared minus 2x minus 15, the factors of negative 15 that add up to a negative 2 would be negative 5, positive 3. Okay, from the x minus 5 to my new denominator, I'm missing the x plus 3. So then x minus 1 has to get multiplied times x plus 3. And so you can leave it really x minus 1 over x plus 3 over x minus 5, x plus 3. In ALEKS, you're going to be asked to do problems where you're just going to find the equivalent fraction. So you could multiply it out if you want to, but you could just leave it with your parentheses as well. Answer is correct either way. Okay, let's look at E down here. I'm sorry, C. I don't have this side factored, so we need factors of -7 that add up to a +6. So that would be +7 and a -1. So from the old denominator to the new, I'm missing x plus 7. So I need to take x times x plus 7. So when I multiply that out, that gives me x squared plus 7x over x minus 7. X minus 1. And you know, the ones that just had distributive property are ones that I was multiplying out. I didn't multiply out that previous example, but you could do it. You could FOIL it and it would still be the right answer. All right, this last one, I've got just variables with exponents. So to go from x to x squared, I'd have to multiply by x. To go from y cubed to y cubed, that's the same thing. I don't have to multiply anything by the y's. To go from z squared to z to the 5th, I'd have to multiply by z cubed. So I'm taking the 6 times those. So that's going to give me 6xz cubed over my new denominator, x squared, y cubed, z cubed.